Hi guys, so this is the small little interactive system I've made. It's basically a little game that uses an LED, a buzzer, to show you a pattern. So the buzzer will beep and then the LED will flash, and it's which ones happen after which ones. And then you have to enter the pattern via the button here or the tapping the light sensor here. So the button would indicate a buzzer, the light sensor tapping would indicate that the LED went. So the buzzer, so the pattern plays first, and you've basically just followed the on-screen prompts, and then you enter the pattern after this. I'm running on just a Raspberry Pi and the Grove board, but I imagine that this would be pretty easily translated to the Arduino as well. So let's see what it looks like. So here we go, the code's just loading up. And you just follow the on-screen prompts pretty much. So it will give you a countdown, play a pattern, and then you need to enter the pattern. So the first two patterns I know because I've hard-coded them, but the last two patterns are randomly generated inside the program. Doesn't necessarily mean I get it right all the time though. See, just did it wrong. That's alright. There's also a little bit of instability with the light sensor because if I don't tap it properly in the right manner, it will think it's been tapped. But that's just what I have to work with. So wow, I'm not doing very well. Okay, let's try again. Oh yeah, I did do it right. Great. And then you can hit the button to retry again. If you retry again, it's the same pattern. It's not randomly generated, it's only randomly generated if you restart the program. I'll now run through the code.
Hi guys, so this is the code. First thing you'll notice, I'm actually in Visual Studios and I'm actually coding in C#. The reason for that is I am very familiar with C#, I already work in it. And so when I found out that I could run the Raspberry Pi in C#, I did. I love C#, I love Visual Studios, and so it all just kind of made sense for me. To do this, to set up the Raspberry Pi to run C# and in Visual Studios, I'll link a link to the tutorial in my main PDF. But it was very easy, it just took a little while, and it's great. The only maybe downside is that the Raspberry Pi then runs a type of universal Windows, a cut down version, which means you can't really run anything else on it, I imagine, but it's possible you can, I'm not sure. So I'll kind of talk about this kind of as if you don't know much about code, but yeah, so let's start. So firstly, these are all the libraries. This code will be in the PDF as well. There is a little bit to get through, so just bear with me, and if you have any questions, feel free to post in the forums. Yeah, so these are basically just kind of the libraries that it's using. You don't really need to worry about the namespace or the fact that this is in its own class. Getting down to the important stuff though, so these are all the sensors: the display, LED, button, buzzer, and light. They're declared as the variables themselves, so they can be accessed later on. These are the main colors I use. This is just a container class, so that I don't have to declare the individual RGB integers inside them. This is a constant screen wait time. This is so that the screen, you can read it basically, otherwise it would instantly flash through all the prompts. The patterns, so these are the manually created patterns. A 0 represents a buzzer and a 1 represents a LED. I'll show you how it knows what to do with this later, but it's basically just an array of integers though. And then this is a list, which is just a data structure that holds all of the patterns. And I used a list instead of another maybe array, because lists you can add as many in as you like. It doesn't matter how many you add. You just here you can see you can just keep adding them. So this is where you initialize those variables. So this one was a little bit different to the rest. So this just initializes it to one of the I2C ports, but the rest get initialized here to pins. So you can put in any pin you like here. Yeah, so I've just done these because that's just how it kind of worked with my setup, but you can set them to any pins. The light sensor is to one of the analog pins though. I already talked about this a little bit. This is just adding the patterns to the list of patterns. I'll now quickly talk about all the methods. So this is just the main program really. But before I go through that, I'll talk about all the helper methods, because I basically wrote helper methods to do everything to make it a bit easier. So the first one, this simply just updates the screen with whatever string is passed in, and then it waits for that constant wait time. This is the run pattern. So it basically takes in the integer array as a pattern, and then this is a for each statement, which is similar to a for statement, but it doesn't matter how big this is. You don't have to declare it. You don't need to know anything about it. It will just step through every element inside this data structure, basically. And I is the reference to access at each point. And then a switch is similar to an if-else statement, but you can add in any cases that it's looking for, and it takes in I. So basically, I is the integer, and if I is 0, it goes into this case. If I is 1, it goes into this case. So 0, it goes in, it turns on the buzzer, it waits for 300 milliseconds, and then turns off. And then it jumps out of the switch statement, it waits for another 500 milliseconds, and then goes around again, basically, until we've gone through this entire pattern. And it's pretty similar for the LED. You can see it turns on, it waits for 300 seconds, and it turns off. Nice and easy, hopefully pretty simple and makes sense. So this is reading the pattern from the user and matching it. So this one's probably the most complicated method, but it's still not too hard, really. I'll kind of walk through it. So I've got another list here, which I use to build the user pattern as a match, to then match with the passed in pattern to make sure that the two patterns match and that the user got it correct, basically. So pretty much it goes into this while loop, and it stays here until the user inputs the amount that is the right length of the pattern, and then it will jump out and try and pattern match down here. So it goes in here, it stays in here. If it gets that the button is on, it'll go into here. This is a kind of to make sure that it doesn't get multiple inputs from holding down the button. So as soon as you click the button, it won't go back into here, basically. It'll run this, it'll add this to the pattern match and a little bit of debugging so you can see it happening in the console. And then it won't go back into here unless you take your finger off the switch, basically, so it resets. Same thing for the light sensor here, adds it to the pattern. You might need to change this depending on the light in your area, in your environment, but mine was quite well lit, so this value seemed to work all right. So once you've input the right amount to match the length of the pattern that was displayed, it'll come down here and it will look through both the pattern that was displayed and the matched pattern, and if it finds any that don't match, it simply says, no, doesn't match, jumps out of this loop and returns the fact that it didn't match. Otherwise, it will return true because this is set to true up here. So again, maybe a little complicated, but hopefully not too bad. I'm pretty sure all of this could be translated to the Arduino and probably run almost just as fine. But it's certainly on Visual Studios, it's much more, in C# and on the Pi, it's much more expandable, and you could take it really, really big and really far. So match pattern, so this is the random pattern generator. it just simply takes in an input of how long you want the pattern to be, and then returns an integer array of that pattern. So again, there's another little list here. This is just a random class to produce a random number. So a classic for loop that just goes through, loops through as many times as this length and adds a random number to the random pattern. And the random number is between 0, which is inclusive, and 2, which is exclusive, so between 0 and 1 really. And then you can return the pattern list as an array. Nice and easy. So this method fades the screen, the LCD backlight between colors, so between a new color and an old color. It's a little bit complicated as well, but it is quite easy once you wrap your head around it. So basically the steps is quite important. So this is the number of steps it takes between each color fade. So if you want a nice big beautiful long fade that you can see all the increments between the colors, you would make this bigger. This is pretty big as it is actually. It probably doesn't need to be much bigger than this. You'd also need to increase this so that you could see that fade over a large amount of time. But the total fade time here is 50 times 10, so it's only 500 milliseconds, so half a second really. But basically I extract the RGB values of the old and the new colors. I find out the difference of them divided by the amount of steps. So I know how much to increment from the old color to get to the new color in those amount of steps basically. And then I just have a for loop that goes through the steps amount of times, increments the old color by that step amount, updates the display each step, waits a little bit of time, because if it didn't wait, again, it would pretty much happen instantly because computers are pretty fast. And yeah, otherwise you wouldn't see anything. So that basically, that's it for all the helper functions. Now let's have a look at the main program. So we talked about all of this, and the main program really starts here. So the first thing it does is it fades the screen from black to its primary color, and then gives you these screen prompts, enters this endless loop, and then it comes into here first. And this basically is while the current pattern that we're on is less than or equal to the total patterns that's in the pattern list. And then it will end, it'll do something else. So it goes through, it gives you your prompts, 3, 2, 1 starting, fades the screen to a different color, in this case red, while the pattern's running. Gives you a prompt, and then this runs the pattern. This passes in the pattern number that we're currently on, -1 because like arrays in computing, they all start at 0. 0 is the first element in array or a list. So then the screen fades to green, and then you can enter pattern here. This is a little bit different because I didn't want there to be any delay. I didn't want it to wait before the user can start putting input, because otherwise it cuts off the first little bit of input really, if you wait after that. So then we read the input, and if it matches the pattern that we've passed in, as I showed you down the bottom, this will be true. It goes in here, it says, yeah, you got it correct, and it adds another 1 to patterns correct to show you at the end. If not, it shows you that you got it wrong, and it doesn't add the correct patterns. It then increments the number of the pattern number that we're on, and then fades back to the main color, the primary color, which is 1. So it goes through this for all the patterns that's in there, dependent on how many patterns you've added in here. And then once it does all of that, it'll go into here. This is set to false to begin with, up here. It'll go into here. This has to run only once, because if I had this outside in this loop, it'll update, you know, like 20, 30 times in a second, and you won't actually be able to read it because the screen will be flashing so fast. So this only runs once to set the screen with your score, and if you want to retry, and then it just kind of stays in this loop waiting to hear if you say yes on the button. And if you do, it says it to true, so it jumps out of this while loop, and it resets the pattern number to 1. sets this to false, so it'll come back into this while loop after it goes through this loop again, comes back up here, and goes through this loop again. Hopefully that's made sense. It certainly takes a little bit of time to just walk through all the code like that. But the best part about this, I think, is that I made it in a way that you can add in any patterns that you want. There doesn't have to be 4, there could be 5 manually. You can add in random patterns. You could add in 10 patterns. It's quite extendable. You could add in more sensors, more displays. Yeah, so you could make quite an interesting, cool game out of it, I think. But yeah, so that's kind of a little tutorial. If there's any questions or if anything's confusing, feel free to put it in the forums. Thank you very much.